Alright, so here we're looking to factor this multi-term polynomial with a negative leading coefficient, this minus 12x to the 7th plus 6x to the 6th plus 15x to the 5th minus 18x to the 4th plus 3x cubed. And basically with this one, and in fact with any general polynomial that you're looking to factor, if you can, you want to take out a greatest common factor from all the terms that you see in one shot. So essentially you're going to be looking for the biggest thing, both in terms of coefficient and common variable powers, that you can pull out of everything at once. So in this particular case, as noted, the leading coefficient here is negative. Well, whenever the leading coefficient is negative, when you're pulling out a greatest common factor, you want to pull that negative out along with whatever other greatest common factor materials you end up taking out of each term. So the negative's out because the leading coefficient's negative. Then you want to focus in on the numeric coefficients themselves. So regardless of sign here, you got a 12, a 6, a 15, an 18, and a 3 basically. So you're essentially looking, for purposes of greatest common factor, to pull out the biggest factor that would go into all of those evenly. And in fact, the number that goes in divides in evenly to 12, 6, 15, 18, and 3 is 3. So 3 then is the numeric part of the greatest common factor. It's the biggest thing you can pull out of all the coefficients at once. Then you'd want to look over all of the common variable pieces here, and you can see all of these terms here have x in them to various powers. So you're going to be able to pull an x out of all these terms at once. The only question is now, how many factors of that x can you get out simultaneously from each term? And in a case like that, where you've got a common variable in all of the terms, the power that you pull out is the biggest power that's common to all of the terms. So if you look here, you've got x to the 7th, 6th, 5th, 4th, and 3rd. 3 is the biggest common power that all of these have in terms of that x. So then x cubed is what you'd pull simultaneously out of all of the individual terms in the initial polynomial. So there it is. There's the greatest common factor that you can pull out, this minus 3 x to the 3rd, minus because the leading coefficient was negative, 3 because 3 divides evenly into all of the coefficients, and x to the 3rd because x is a common variable to all the terms, and the biggest common power of x in all the terms is 3. And now the wrap-up of the greatest common factorization is to now take that minus 3x cubed out of each of these initial terms that we started out with and just write down the leftovers. What things would you have to multiply minus 3x cubed by each in turn to generate out minus 12x to the 7th, 6x to the 6th, 15x to the 5th, and so on. So if we get to answering that question to finish things off, the thing you multiply minus 3 by to get minus 12 is 4. And then the thing you multiply x cubed by to get x to the 7th is x to the 4th. So I mean, the minus 3 times 4 being minus 12 is a pretty obvious multiplicative fact. Then when you multiply two exponential expressions of the same base, you add their powers. So that's why x to the 3rd times x to the 4th is x to the 7th. And now you just run a similar kind of treatment for all the rest of these. To get 6x to the 6th, the thing you'd multiply the minus 3 by is minus 2. And the thing you'd multiply x to the 3rd by is another x to the 3rd to bump up to that full power of x to the 6th. Then for the next one, to get a 15, you'd multiply that leading minus 3 here by a minus 5. And then the thing you multiply x cubed by to get x to the 5th is x squared. Then move on to the next one. The thing you'd multiply minus 3 by to get minus 18 is a plus 6. And then the thing you'd multiply x cubed by to get x to the 4th is just a single factor of x. And then finally, to switch the sign, to get a plus 3x cubed out of this initial minus 3x cubed, you just come in and multiply it by a minus 1. So there it is. There's the full-on factorization by a greatest common factor. You get a 4x to the 4th minus 2x cubed minus 5x squared plus 6x minus 1 left behind. And then well, you could just check your results to see if you were correct by literally just undoing the factoring, taking minus 3x cubed and multiplying it through all this, and you're going to generate back exactly that initial polynomial we started with. So there it is. There's a full factorization by a greatest common factor.